The chapter, but it's a two-part lesson called Trigonometric Identities. Has anyone heard of this before? Oh, good. Well, I don't want. Yeah, okay. You might have heard about it, and people are like, trig identities. Okay, here's how trig identities go. Okay. First day, not bad. Second day, oh boy. Yeah. And then advanced functions, it gets right off the rails. Okay. So yes, this has a bad reputation. And deservedly so. These can get very, very difficult. Reminds me of like Sudoku puzzles. You can do Sudoku puzzles like, oh, and then same puzzle, less numbers, and then it gets really impossibly hard. Okay? So my job is just to show you some techniques. And just like Sudoku, as you learn more techniques, things get a little easier. Okay? So first, what is an identity? An identity is a mathematical expression that is always true. There are some mathematical expressions that are always true. Here's an example of one. 1 plus 1 equals 2. Yeah? It's true. 1 plus 1 is always equal to 2. That's as simple as what the definition of identity. We can all agree 1 plus 1 equals 2. 3x plus 2x is equal to 5x. No matter what x you put in there, that's always going to be true. The left side's always going to equal the right side. Because 3x plus 2x is 5x. That's a mathematical identity that you already know. You know that 3x plus 2x is 5x. I hope you do. Yeah? That you can add those two terms together. And we can make a list of other ones, but I don't want to get sidetracked. I want to stay on the idea. The idea is I can write down mathematical expressions that are always true. Let me write down a mathematical expression that's not always true, and it might surprise you. 5x equals 10 is not an identity. That's not always true. It's only true once. There's only one x value that makes that true. Only when x equals 2 is that true. Okay? So now that's the definition of identity, something that's always true. It doesn't matter what x you put in, it's always going to be true that 1 plus 1 equals 2, that 3x plus 2x equals 5x, but 5x equals 10, that's not always true. I'll do another simple one. X squared equals 9. That is not an identity. That is not always true. If I choose x equals 10, this won't be true. You're like, well, you can't choose x equals 10. I'm like, I can choose any x value I want. We've just been working on situations where we go, what x values make this true? And then we'd find out that's true for x equals plus or minus square root 9, x equals plus or minus 3. Did I need all those steps? No, I was just being technical there to show all the steps. Only x equals plus or minus 3. And you say, well, we never wrote that before. We never wrote only if x equals plus or minus 3. I'm like, I know we didn't write it like that, but that's what the implication is. We're finding the x values that made this work. Today's game is not that game. Our game will be prove that something's true. This is always going to be true. Identities are about them always being true. Now, could I ask a question? Prove this isn't true. Yes, I could. But 99% of identity questions are prove this is true. Okay? And we won't get sidetracked by proving things aren't true until we're pretty good at proving things are true. Okay? Advanced functions people. There's a couple questions in your homework that's like, ooh, prove this one's not true. But let's get really good at proving they're true first. Okay? Oh, look, Cap, I broke out the bold. Our job will be to prove that a trigonometric identity is true. And I'll just say, maybe we could prove they're not true, but we won't do too much of that. That means proving the two sides are always equal. You're like, that scares me. I don't know how to do that. I'm like, that's fine. That's what I'm here to teach you today. So let me just highlight that. I'm learning here, improving every day at this. You want to highlight, use the other hand. Yeah. I've got a second pen too, so I'm going to figure that out. Maybe I can get two pens going at the same time. You say, fine, how do we do that? Well, you get a really good teacher to come by and show you how to do it. So here I am. The best answer has two parts of what we're going to do to prove these things are true. I hope somewhere along the way you ran into a left side, right side check. If not, that's okay. I'll show it to you today. But I hope that's a little familiar. We're going to separate these things into left side and right side. Then, work on each side until both sides are equal. If you're right with me, you're like, that's not very good advice. That's what I'm worried about. How am I going to prove they're equal? I'm like, yeah, I know. I'm not done teaching the lesson yet. But here's the basic plan. See? Separate into left side and right side, and then work on each side until both sides are equal. Okay, follow-up question. What do you mean work on each side? Like, yeah, that's the lesson. Now we're finally to the lesson. How do I work on each side? Okay. Do you have any questions? Maybe there's no question to have. Maybe just stunned silence is all there is. Like, I don't even know what's happening yet. Until I get to an example, I don't have any question. I'm with you, sort of, but I don't know what's happening. All right, that's good. More time here? There's the basic plan you go to. I don't even know how to start identities. Go back and reread this and go, okay, the basic plan is separate to left side, right side, and then work on each side. Now, we will need a trigonometric toolbox to accomplish this. Now, I put it in quotes because right now you don't know what I'm talking about. And advanced functions people, you'll literally be given a toolbox. But I'm going to build a toolbox for you. Here's some identities that you already know. Our toolbox has some identities that we can use to work on ours. We've got some identities already in our pack. Now, our current toolbox, I'm going to write some stuff over here. So write all on the left side here, because I'm going to add a couple today. Okay? So here's the ones you already have. Don't be scared. As soon as I write them, as soon as I write what you already know, you're like, oh, yeah, okay, I remember that now. Here's one you already know, or have seen. I hope you know it. Cosecant. It's 1 over sine. Secant. 1 over cos. And cotan equals 1 over tan. There's your current trig toolbox. And I'll say it that way every time. I'll try and say it dramatically so you know what you're looking for. Those are the current set of weapons we have. Now I'm going to go to the armory and arm you up with some new weapons. Some new trig things, and I'll put them over here in the trig toolbox in a second. Then we will go and battle identities with our full toolbox. Right now, that's not a very good toolbox. Two great things in the toolbox. You'll think I'm lying, but I'm not. The second one has some options. Okay, well, we'll get to that in just a second. What's that? Oh yeah, weird day, right? Lunch-wise. I don't know what that's going to do for you math help room people, the people who come to the math help room every day. I do both math help rooms. I'm not bragging. I'm just telling you the situation. So by the time you get to senior math help, I've already done junior math help, but I can't do that today. I got to stay in junior math, so I can't get over to senior. So you seniors that want to come for math help, come here to this room. What's that? I can't play basketball, and I'll tell you why. My knowledge of parabolas and trigonometry makes me too good at basketball. It's not really fair. Yeah.
I see that. You get the right arc and everything.
Yeah, it doesn't make any sense. Yeah? Yeah. You ever see the Avengers movie? You ever see the Avengers movie? Hawkeye's like, yeah, I went and played golf. Played 18, shot 18. Came home. Yeah, doesn't make any sense.
So what, is that you?
Yeah. No, yeah. Yeah, it's just a parabola, a little bit of trig.
Could you teach me sometime?
What's that?
Could you teach me?
Yeah. First this. Let's get a couple more identities for our toolbox. Check this one out. Really scary. Apparently, sine theta over cos theta has some magic. Ready? Here's the magic. Vital. Vital. Ooh, here we go. Vital identity.
Is that what it's called? Always getting a red highlighter out. That means it's important. It's important. Oh, wow. It's not thick enough.
That's not a highlighter. Yeah, I know. Highlighter. Red. Money, buddy. Vital identity number one. Sine theta over cos theta. You're like, what could you possibly do here? Well, hold on. You're not. Sine theta over cos theta. Sine theta, I'm just teaching the grade 10s, is opposite over hypotenuse. Okay so far? Yep. Haven't blown your mind so far. You're unimpressed. Hopefully. You're like, oh yeah, I remember that. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. I'm using the full letters here on purpose. Fraction in a fraction. And we've dabbled with this in the past of what to do when you have fractions inside fractions. So instead of writing it that way, I'll do the easiest way to handle fractions inside of fractions is I'll use a division sign to help myself out. Opposite over hypotenuse divided by adjacent over hypotenuse. That's easier to look at. It's not technically doing anything. It's not easier really, but for most people that's easier to look at. Now, does anyone remember how to divide fractions?
Yeah, you would just divide them.
No. You reciprocal the second one and turn it into multiply. Now reach down under your chair and grab the seat belt that's there and do up your seat belt for what's about to happen next. Because you're about to dig trig. Like right after this, you're going to go up to that t-shirt store up at the Conestoga Mall in Kitchener and you're going to order an I dig trig t-shirt. Because you're going to be like, whoa. Just stare at that for a second. I'll change to cancellation gold. Can you see the cancellation? Whoop, whoop. The hypotenuses cancel, and I'm left with opposite over adjacent. If I need to scroll back up, let me know. Did you do up your seatbelt? Make sure it's done up tight so you literally don't get blown right out of your chair here. Opposite over adjacent. OA. What's opposite over adjacent? TOA. 10. Come on. I just ruined your day. Here's why. You can't possibly go to another class and see something better than that today. I don't care what movie they're showing. It doesn't get any better than that. That's it. That's the high point of your day. It's all downhill from here. You got a cookie, and sine theta over cos theta is tan theta. Back to your trigonometric toolbox. Tan x. I know I use thetas. Get over yourself. It doesn't matter what variable's in there. And now a bonus Christmas gift to you in green. And something for you to do. Whatever your boring class is today. Don't say it aloud. Just think about what's the math. This needs a dart in the end. My bonus helpful identity. If you're not sure why this is true, good. That's part of your homework. Or maybe you're like, oh, obviously. If tan is sine over cos, then cotan's cos over sine. I made a mistake there. I got talking. Eraser. Oh, look. I made the eraser on my finger. I made a little mistake there. I said x, but I wrote theta in there. So please fix your beautiful trigonometric toolbox. Tan x is sine x over cos x. We could do it all with thetas if you wanted to. It doesn't really matter, but I did my toolbox with tan. Okay, so this isn't what the chapter is about. You don't have to do this. Boy, it's nice to look at. And no, I'm not just making this stuff up when you see tan as sine over cos. Using math that you can follow, tan is sine over cos. And with that, cotan is cos over sine. Is it okay? All right. Now our toolbox is getting bigger. Now we've got more options. We've got more choices in our toolbox, more weapons we can use. Let me show you vital identity number 2. This would be legendary scar. Now, am I saying that right? Is Dion's nodding? Good. Just me and Dion on that joke. Okay, that's okay. I don't care. This is the legendary scar. Look it up. Right? For the rest of them, look it up. Fortnite, the best weapon, is it? No? It's up there. What's the best weapon? If you had to choose, would you take the legendary scar?
I mean, it's not really in the game anymore.
Sort of like me, right? Yeah, all right. Sine squared theta plus cos squared. It's just a joke. I'm okay. I'm okay. It's just a joke.
It's just a joke, Carter. Call him Todd. Where's Todd?
Sine squared, apparently some magic's going to happen here. Apparently sine squared theta plus cos squared theta is something all the time. Get ready. But don't let me away with it. Don't just write it down and go, I guess Mr. Todd says so. Make sure you follow the steps. This is the kind of thinking we got to be able to do. That means sine theta squared plus cos theta squared is something. Mr. Todd says this is vital. Something happens here. And the squared is just mathematical laziness that we put the squared inside the sign there. This is really what's going on. Anytime you go to actually do something with sine, you'll put the squared outside the brackets like this. And what is sine theta to the grade 10s? And to you, before this chapter, it's opposite over hypotenuse. I'm going to write the whole word. I'm not going to be lazy. Opposite over hypotenuse. And that's all squared. Plus adjacent over hypotenuse. No matter what angle you talk about, whatever theta you're talking about, that's just going to be equal to the opposite over the hypotenuse. And you're right. If this was theta and this was something different, what I'm doing wouldn't work. But for any angle that you want to talk about, sine theta will be opposite over hypotenuse. Cos theta will be adjacent over hypotenuse. Using our exponent laws, we can just take the squared and put it on both things. Everything gets squared inside. And this time it's not multiply or divide fractions. This time it's add fractions. What do we need when we're adding fractions? We need a common denominator. We need both denominators to be the same. We already got that. I can add these together. Now don't reach down under your seat for the seat belt. Reach behind your chair and get the big over-the-top bar, like on the behemoth, because this ride goes upside down. You got to strap in for this one. Opposite squared plus adjacent squared. Maybe you need a little diagram to see it. I don't know why I wrote a C there. There was absolutely no reason.
A squared plus B squared equals C squared. Pretty sure that's what it is, right?
Opposite squared plus adjacent squared is hypotenuse squared. The Pythagorean theorem is jumping up on the down on the bench going, put me in, coach. I know just what to do here. The numerator is hypotenuse squared. That's the Pythagorean theorem. And what's hypotenuse squared divided by hypotenuse squared.
Canceled.
Come on. Every time you square sine and square cos and add them together, you get the number 1. Now, I wasn't there when the universe was designed, but that must have been one of the first things that came off the reel. Like, look at that. In our universe, that's the way it works out. Could other universes be different? Well, I guess I don't know the answer to that. That is shocking. How many times have I taught that? 400, maybe. And it's still unbelievable that that's the way this thing works out. Giving you another incredible weapon for your trig toolbox. Sine squared x plus cos squared x equals 1. But a little Christmas bonus here. If your algebra is just okay, you might like this on your trig toolbox, which is just those two things rearranged a little bit. Stare at that long enough to convince yourself that I did basically nothing there. I moved the sine squared over to the other side, or I moved the cos squared over to the other side. You'll find those very valuable. And if your algebra is just good, you might want them right on your toolbox. People who are good at algebra are like, didn't you just move it over? Yeah, thanks for moving it over, but I can handle that. But I'm not saying anything about it. I'm just trying to talk to two different groups of people at once so they both can understand what I did there. Now I'm ready. What happens in Fortnite? You go to an island? Is that what? Now I'm ready to parachute into the island.
You gotta jump off the bus, yo.
Is it a bus now? I thought you parachuted into, no, parasailed?
Yeah, you gotta jump off the bus, though.
Battle bus, parachute, and take all this stuff with you as you go. You non-Fortnite people are like, what? I don't even know what I'm talking about. I just got some people to give me these sentences so I could use them. Ready, player one. Press start. Boop. Lesson actually starts now. Dun, dun, dun. Prove the following identity. Must be in left side, right side format. So, putting it all together now, here's what you do. You go, okay, I'm going to work on the left side over here. Can I just write LS? My grade 9 teacher said I could just write LS. Yeah, okay, that's fine, but I'm not going to do that in the first one, okay? I'm going to write left side, right side. Draw a line down the center, and I'm going to go, this side says secant theta times 1 plus cos theta. And this side says 1 plus secant theta. And it says prove that this is always true. Nobody I know can look at that and just say, yep, I see it's always true. Everybody I know has to do some work here. What is all the work? Well, you've got a whole bunch of weapons, algebraic weapons here. One side doesn't have brackets. One side does have brackets. That's got to be first. But that's the challenge of identities. Some people look and go, I don't know what to do first. I'm like, well, do something. It's like going to your garage or your bedroom, and you're like, it's a complete disaster. What do I do first? I'm like, I don't know. Do something. Don't do nothing. One of the options here, how about multiply out the brackets? This side doesn't have brackets. If these are going to be equal, I got to get rid of these brackets. So I'm just going to multiply this in. And I get secant theta plus secant theta cos theta. And just, I don't want to talk about marks and tests too much, but just from a testing standpoint, and getting you a mark. You know, if this thing's out of 4, I've already got a mark. I already did something here. All right, now some drama to try to help you to know what to do next. This question has cos theta in it. There's a cos right there. So the first set of identities on your toolbox, here's what they actually accomplish. After all this, some people are like, I get why you might at this point think, I don't even know what these are for. They're for this exact situation. If I want to, any question you want, I can go to sines and coses. If they give secants, cosecants, cotangents, feel free to not like those, because you can always get rid of them. You can always just go, okay, if I see cosecant, I can write 1 over sine. If I say secant, I can write 1 over cos. And if I see cotant, I get 1 over tan. And I can get back to sine, cos, and tans. And that's a good move in these questions, is to go, let's get it all back to sine, cos, and tan. So that secant is 1 over cos. This secant is 1 over cos. Now that I'm all in sines, coses, and tans, and in this case I'm all in cosines, maybe there'll be some cancellation. I'll look around and see, does anything cancel now that they're all coses? Look at that second one. 1 over cos times cos. Maybe you need another step to see it. I'll show another step. 1 over cos plus cos over cos. What's cos divided by cos? 1. Of course it is. You can be mad. There's only one of 2 responses I enjoy when I tell a joke. I either want laughter or you're mad. I like mad. That's a better response. And then you get to the point in identities, and this is your first identity example. So it's not like you're too stressed just yet. You will get stressed by identities, by the way. But then you get to this point where I don't know what else to do over here. So you also got to get good at looking back and forth and going, well, I did all I could do over here. Let's go over here. And you say, oh, there's a secant over there. I made the decision to go to all the coses, so I better do it over here as well. Oh, it's the same, he says. Do I need another line here? Are you convinced of the same? Yeah. Both sides are 1 and 1 over cos. And then so you write something fancy here. Every teacher, every prof out there writes something different. Therefore, left side equals right side. Some teachers like writing, therefore, true. Really advanced proof courses, higher mathematics, they write 2 big slashes like this. And those 2 big slashes mean, yeah? I've seen QED wrote, I've seen a little square. Say, ah. Yeah? So all of these symbols mean the same thing. That's just for people going on to upper math. If you're going to go up to upper math, you might see all of these things done when you finish your proof. For us, left side equals right side, true. Huh? There, that's the game of identities. I finished the whole game. Everyone after this is the exact same game, except it might play out differently. That's what you do. You parachute on the island. You use your trigonometric toolbox to play around with left side and right side until they're equal to each other. Any questions about A? No. Now we will do B. And I won't even charge you. It'll be a freebie. Or sarcastic laughter. I enjoy sarcastic laughter too. More time here? Folks, you have to approach these like you would approach Sudoku. This isn't like regular math, where you're just going to be like, boop, through the homework, zip, boom, done. Yep, factor, 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 done. It's going to be like, what do I do here now? What about this? How do I do this one? You know, they're torture on purpose. Don't get too upset. Don't have an identity crisis over this. What should I do first? Side by side. Left side, yes, you can just write LS and then RS over here. Now me personally, I don't put the dividing line just anywhere, because when I look at this, I look at that left side, I'm like, there's not going to be much work over here. So I'll just leave a little bit of space over here. On this side, I'll leave a lot of bit of space. They say prove that it's always true that secant theta equals tan times cosecant. Do you already have a strategy here?
Yeah, that equals 1 over cos theta.
Right, you've already got a major big strategy. What's the first weapon you start with in Fortnite? You just get a knife? Just a big axe. Those ones on the left are your big axe. You're like, well, before you do anything, see if these are going to help. If there's a secant, a cosecant, a cotan out there, hammer those. So, secant, boom, 1 over cos. And then you're at a loss because you're like, I don't know what else to do. And the identity goes, that's because there's nothing else to do over there. You've done all you can do. You better go look at the other side now. So I go over here and I go, okay, I see cosecant. What's cosecant? 1 over sine theta. And then you're at a loss of what to do next. So you get out your trig toolbox, you look through your pile of weapons. Ooh, this lesson's in 3D. You almost got it nailed there. Huh? And you look through your box and say, is there anything else in my toolbox that maybe I could use to play around with what I see here? Does anyone see another identity that might be I don't know, might be of some use? Do you see one?
I don't see it.
No, nobody sees one that could potentially use? Yeah? Anytime you see 10, you could write sine over cos. Now, I'm not saying you should. I'm saying, well, try it out. That's one of the weapons here. Let's see if the axe will take care of this situation. No, it's not an axe. The shotgun. We'll get out the shotgun this time. 10 is sine over cos. And maybe you already see it.
Yup.
But if you don't, go ahead and multiply the fractions together. Some people, the cancellation annoys them here, that we're allowed to cancel those signs right there. Some people want the other step. It makes them feel better to multiply these two fractions together. And I wrote the sign first, but there's no reason you have to write the sign first. And I'll switch to my cancellation orange. Some people are already ahead of me here. Geez, I'm getting a little better, eh? A little better.
That cancels 1 over cos theta. Yeah.
Equals 1 over cos. Therefore, left side equals right side. Therefore, true. Again, if there was a Sudoku puzzle on the board, and I went up there and said, here's how you do Sudoku, and I went through it, you'd watch and go, wow, these are really easy. Sudokus aren't really easy. You got to do them yourself. You got to hammer, cancel all your plans this weekend. Just identities. And it's great for getting out of chores. It's another topic that will stop parents and relatives cold. Like, hey, can you come and help rake leaves? You're like, well, I could, but I got my trigonometric identities homework. And they're like, woo, 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 never mind. Let me make you a sandwich. You just stay in your room. Do trigonometric identities. Everybody knows what they are. Everybody's heard of them before. Questions there? How many more I got to do? I got to get this lesson done in time here. Oh, I got 35 minutes. Yeah, this isn't the bad lesson. Wait till Monday. Yeah? This one's okay. Ah! Look at that mess. First step, Hazel. Left side, right side. And this time I don't know which one is going to be more work. So I'll leave lots of room on both sides. Let's collect some ideas. Oh, they're probably making a video or something like that for the final day or something. They're outside. I can see them out there, and there's several instruments out there. Let's collect some ideas, because lots of times people will text or email me or ask me a question about identity and go, where do I start? I'm like, I don't know. I don't know. Just look at it and say, what could I do? You got your trig toolbox. Look across there and look. Let's get some options together. What options do you see out there? He's doing the right thing. Flip into the toolbox. Let's look at the toolbox. Mr. Todd, do I have to memorize the toolbox? Well, that's a very good question. Let's not get sidetracked on that just now. Let's just pretend we have the trigonometric toolbox either on a sheet of paper or we've got it memorized. What do you see that could possibly be used? Hazel? Pythagorean theorem 1, yeah. Anytime, once you see squared in a question, you can almost feel the Pythagorean theorem identity jumping up and down the bench going, put me in. I can help. Okay, so we could use that here. We could use that there. There's multiple cosquares there. So we've generated an option. We've got something we could try. What else do you see? in your toolbox that might be of some service here? Tiana, can't tell if your hand's up if you're just stretching. Your hand up? Good. Sine over cos. All right. So we got options here. Which one's going to work? The answer is I don't know. I don't know. Maybe I do know, but it doesn't matter. Try something. See what happens. Which one would you like to try? How many people would like to try tan? How many people want to do something with the Pythagorean identity? The vote was 2-1 in favor of the Pythagorean identity. It was a highly contested vote. That vote is a lot like the votes that go on in this country. Oh, they won a rousing success. 40% of the people came out to vote. I'm like, think they really won anything. Nobody came. Pythagorean identity. Now take a close look at this thing over here. 1 minus cos squared theta. Do you see it on my identity box? It says, if you see 1 minus cos squared, you can make that right into sine squared. You can go right to left. That might be weird to you, to go right to left in one of these identities, because that's not really how we've used equations before. We usually go left to right. I'm here to tell you, right to left is the exact same thing. 1 minus cos squared, I could write sine squared. That's a big leap. That is a tough jump. But I could write, instead of 1 minus cos, I could write sine squared theta. That's a pretty good situation. Okay? Then over here, I'll show 2 steps. We're going to do the other move that was suggested, was to take, oops. I didn't mean to write that. I meant to write, take tan theta, write the brackets on and put the squared out there. If you're going to do anything with a squared term, put it into the brackets. Then I get cos squared theta, and this is sine theta over cos theta, straight off the toolbox, but that's all squared. And exponent laws tell me I can go ahead and square the top and the bottom. He says it's over 1, so they cancel out. Actually, he gave all the information you need to. If you're fractions, some people are like, I'm good at fractions. I'm like, I know, but being good at fractions and being good at trig fractions can be a slightly different thing. You got to really apply your knowledge of fractions here and go, okay, if I wanted to multiply these 2 fractions together, I got to put that one over 1. Then I can multiply the numerators,
Cross out 1 sine.
multiply the denominators. Now I can get out my cancel pen, which I'm using gold for. Those get canceled, and I end up with sine squared theta. Now, if you're out there going, I'm really confused by these steps, I'm like, I know, trigonometric algebra can be very challenging to be able to see this in perspective and see the fractions, everything. So then you look over and go, well, that's all I could do there. I guess I must have to do something else. Oh, it's done. And identities are like that sometimes. You don't see the done coming, and all of a sudden you're like, oh, done, finished. It's all done. Therefore, left side equals right side. And plenty of solution books only write, therefore, left side equals right side. They should write, therefore, true, but sometimes you don't see them do that. Or sometimes they just write, therefore, true. I'm not going to get sidetracked by that in this course, about what you write there. I'll let your future proofs course, or proofs prof, get carried away with those things. I see a couple frowns. That's good. We're supposed to get right up to the spot of almost frowning here. Yeah? Where it's like, this can get out of hand. This could really get out of hand. And that's exactly, I want you to think about Sudoku. Sudoku can get, you ever seen one of those books that says, seriously challenging Sudoku? And then the ones that say, almost impossible Sudoku? You can get a book of things that are like, what am I supposed to do here? Yeah? And that's the way identities can go. Plan of attack for proving identities. Go back to this when you're not sure. Here's the plan of attack. 1. Hazel. Separate into left side and right side. 2. Now comes a whole bunch of advice by Mr. Todd. As you head off to the island, this is things I'm yelling at you as you're getting on the bus. Don't forget to, hey, do this. Good luck, I hope you make it. Yeah? 2, work on the more complicated side first. I didn't say that in the lesson. But there's my next piece of advice. And I'll put a question mark at the end. This isn't always the right strategy, but for a lot of questions, you'll find better results if you just go after the more complicated side first. 2, be aware of sine squared theta plus cos squared theta equals 1.
You wrote 2 twice.
When you see any squared terms. Anytime you see squared terms, reach back and take sine squared theta plus cos squared theta equals 1 and put it in your front holster. And you're like, maybe? Sine squared theta, cos squared theta 1? Yeah? 2. If you see any sine x or cos x go to all sine x and cos x. The trig toolbox always allows you to accomplish that. If you want things in just sine and cos, you can always do it. If you get secant, you can go to 1 over cos. If you get cosecant, you can go to 1 over sine. If you get tan, you can go to sine over cos. So you can just go to all sines and coses. Two, multiply out brackets. If there's brackets there, multiply them out. And then finally, today, my final piece of advice is to do the fraction work. Add and subtract. You need common denominator. You don't need that for multiplying and dividing. Those are the easier operations. And if you're not going to go home and practice any of this stuff, then the identities are going to beat the heck out of you. I don't mean to say that in a frustrated voice. I'm just saying you just can't continue to ignore this homework and think things are going to go well, because it's not. It's going to go very bad. You're going to have blank identities because you won't know what to do. Nathan, you have a question that I've been cleverly ignoring for a little while.
No, I'm just confused with if you see any sine x or cos x go to all sine x.
Oh, yeah, okay. So that's a little bit more. I thought you were going to ask about, you have another question that you're asking. Okay, so this question, the first one, I saw a cos. Yeah. So I immediately stopped and went, let's just go all the sine and cos. If there's sines and coses in the question, let's just go all sine and cos. So if you see any at all. But there are some questions where there's no sine and cos at all. You might not want to go to sine and cos. It'll work, but it might be easier to not use sine and cos at all. But if there is any of them there, you may as well go sine and cos. So once it happens, do it. Can anyone answer? I don't know. I don't know. The way I've taught, why is there so many twos? Because I don't know which one you should do first. It depends on the question. Here's a bunch of weapons you might use. I don't have an order here. This isn't like solving quadratics where I said, here's what you do. You bring everything to one side. Then you try to factor it. And if it doesn't factor, you use the quadratic formula. It had a recipe. Identities, this is what bothers people about identities. It doesn't have a recipe. It has a bunch of options you could do. So instead of being a house builder, you're now a house repair person. You show up and you look at the question and you go, okay, I don't know, what's the problem? What am I going to do here? I don't know which tool I'm going to start with, which weapon I'm going to use. There's multiple ways to handle the situation. And that really bothers people. That's what bothers people about identities. There's no specific plan here, just a bunch of advice. And then on day 2, it gets even worse. Sorry, I'll try and scroll that down. Oh, I did it. Do you have any questions? Last slide. That one? Am I scrolled down far enough for that one? How much better was I with the pen today? I don't know if I deserve an A yet, but I might be a B minus now. What's that?
You're amazing with it.
Can't tell if he's being sarcastic. Look at the uniforms today. Perfect, perfect, perfect.
Nathan.
And Danny.
Yeah, Danny and Nathan messed up equal.
Come on, Danielle.
-1 on the next test. You 3.
See this?
I'm keeping track.
-1.
Oh, yeah. Every time I have to fix sweaters next week is a tough identity I put on the test.
Please no.
What?
No.
Yeah.
I beg of you, no.
Starting on Monday. This will be good. See what I've done? I've turned you against each other. Doesn't matter to me. I know tough identities. I know lots of tough identities. I'll just put them on the test. I'll call them sweater question number 1 and sweater question number 2. And you'll be like,
Why don't you just put them on the people who are
no, what fun is that for me?
We're a class.
I deserve a joyous Christmas too. That's no fun for me.
So if I don't wear the uniform, everyone gets -1?
No, you just